Hey everyone, welcome back to the channel. I hope you are doing extremely well. Let's solve this question which has been asked in today's biweekly contest. The question is replace question marks in a string to minimize its value. What question is saying you are given a string S. Si is either a lowercase English letter or question mark. That means we have given a string where each at each index either the value is A to Z, or in some places you may find a question mark. Next, it is saying for a string t having length m containing only lowercase English letters, we define the function cost I for an index I as the number of characters equal to ti that appeared before it in the range 0 to I minus 1. Basically, this is the definition. Calculate the cost of a character at each position. That means, suppose we are given a string A, B, C, B, C. Now, if I say what is the cost of index 2, then how we can calculate it? To calculate the cost of index 2, we have to see that at index 2, what is the character? The character is B. Then now we have to see how many characters before this index are appeared as B. If we see for this index 2, there are none of the characters before this index 2 where B has appeared. So the cost of t will be 0. Now, if I see cost of 4, if I calculate the cost at index 4, we will see how many times character B has appeared before index 4. If we can see only one time B is appearing, that means cost of 4 will be 1. So similarly, we have to calculate cost of each index from 0 to n minus 1. And upon summing all this cost, if we do a summation of all this cost, we will get the value of a string. Now, if you remember that in some places there is question mark, right? So task is the task is to replace all occurrences of question mark in S with any lowercase English letter so that value of S is minimized. So since if we in place of question mark, if we put any random value from A to Z, then we might get different cost or the value of a string. So we have to minimize that value by replacing the question mark with any characters from A to Z. After replacing, after we have find the minimum cost of the string, after replacing the characters, we have to return the same string again. Turn as after replacing question mark. So I hope question is understood. Now let's see how we can approach. So before that, I want to show you one intuition. Now let's suppose we are given a string. Let's suppose we are given a string B, A, B. Now, if I ask what is the cost of the string, if I calculate cost of index 0, the cost will be 0. Since before this index, there is no occurrences of B, the cost of this index will be 0 because before this index, there is no occurrences of A. Now, before this 2, the cost of 2 will be 1 because before this index, only one time A is appearing. Now, cost of 3 will be 2. Since 2 times A is appearing, cost of 4 will be 1. Since before this index, one time B is appearing. So overall cost will be 4. Now let's reshuffle this string and again find out the cost. Now we use the same characters after shuffling. Now let's find out the cost again. Now let's see what is the cost of A. That is cost of zero index. That is 0. For 1, it is 0. For 2, it will be 1 since one time before this index A is appearing. The cost of 3 will be 2 since 2 times A is appearing before this index. Now cost of 4 is 1 because one time B is appearing. Now again we can see the cost is 4. Now let's take one more sequence of this. Now let's suppose we keep all A's in the beginning and then 2 B's. This time the cost of first index will be 0, second index will be 1, third index will be 2, fourth index will be 0, fifth index will be 1. Now again we can see the overall cost is 4. Now let's keep B first and A at the last. The cost of first index will be 0, second index will be 1, third will be 0, fourth is 1, third is, fifth is 2. Again we can see the overall cost is 4. So from this, I want to conclude that it doesn't matter what are the sequences of the character. Even if we shuffle the characters, the cost will, even on shuffling, cost will not change. So how to get this intuition? So suppose in this only, if we see, now let's take this example, A, B, A, B, A. This is what we have 3 A's and 2 B's. Now, if we want to calculate the cost of this character, not only the cost of this character, because of this character, how, how much value it is giving in the overall cost. Because of this character, in the overall cost, how much value is being added. If we see for this A, what we have to see? Because of this A, how we can get the cost. In overall cost, not only for this particular position I am saying. Overall cost, how the overall cost is impacted because of this A. If we see for this A, how many times A is appearing before this index, that will be one cost because of this character. That means how many times it is appearing before. And if we see for this A, the cost is 2. Why? Because of this A and this A. That means in overall cost, because of this A also, 1 has been added because of this A. That means in the right hand side, how many times A will appear for every character. Again, 1 will be added for every A because of this A. Because suppose if there is A and later on there are 4 A's. If we want to calculate for this A, the cost will be added 1 because of this A. For in if we want to calculate the cost at this index also, we will see we will add 1 because of this A also. For this A, if we want to calculate the cost at this position, we will see that for this, because of this A, we will again add 1 for this at this index. For this A also, we will see because of this A, again, one value will be added. That means how many times A is appearing after this position, that many times, that many values also we have to add. That means if there is a or any character, suppose, how many times it is appearing before and how many times it is appearing after. All this count we have to add as an overall cost. That means it is impacted as the number of A's appearing before and number of A appearing after. So now suppose there are 4 A's before and 5 A's after. So because of this A, in overall cost, 9 will be added in overall cost. Now let's suppose we keep this A at the end after this 4 A's as well as after this 5 A's. Now if we keep this A at the end, now what will be the cost? Again, we can see the cost will be the number of times A is appearing before and number of times A is appearing after. That means now we can see no A is appearing afterwards, only 9A is appearing before it. That means again 9 will be added in overall cost. Though we have changed the position of this A, because of this A, the cost is not changing. It will remain same. It doesn't matter whether we are shifting that A in the rightwards or leftwards. Now, let's see one more intuition. Now, let's see, suppose we have this A, right? Now, if I want to say what will be the cost of this A, because of this A, how it will impact the overall cost, that is 2, 2A before and 4A afterwards. That means overall cost will be 6. Now, let's suppose we have shifted this A here. Now, what will be the cost? Again, we can see 4 is before, 2 is afterwards. It is same. For this A, if we ask what is the cost, we can see there are 6 A's in the beginning and no A's at the end. Again, it is 6. So it doesn't matter what is the position of this A. We can easily calculate what is the cost that is being added in the overall cost. What is the value that is being added in this overall cost because of this A, because of B, because of C? Like this way, we can find it, right? So if on changing the position, it is not impacting, that means if I say we have a question mark in the question in this sentence, suppose we have a string in which we have a question mark also. So can we say we can shift all the question marks at the end? Will it impact? Since if we keep all the A in the beginning and 2 question marks at the end, will it impact? So if we now calculate the cost after removing the question mark, it will be some value. Let's suppose X. Now, if we calculate this cost, it will also give X only. Now, because of this question mark, now let's suppose this question mark is A. If this question mark is A, that means before this A question mark, there are 2 A's. And after this question mark, there are 4 A's. Now, since we have shifted this question mark here, now if I ask what is the value because of this A, we can easily see it is again 6. There is no change. That means it doesn't matter whether we shift the question mark at the end or not. So can we say we will shift the question mark, all the question marks at the end, and we have to replace this question mark with some character so that we can minimize the overall cost? And to minimize the overall cost, so if I use A here, that means it will give 6 cost because there are some A's that are appearing before. If there are some B's also that are appearing before, then we should look for C. If there are some C's also that are appearing before, so we should look for D. If D is not appearing, that means D is the best option, because D is not appearing before, that means it will give me 0. Now, suppose from A to Z, every character is appearing sometimes. Every character is appearing. In that case, we will look for the minimum, that character which is appearing minimum time. Now, let's suppose M is appearing only one time and remaining characters are appearing more than one time. In that case, can we say that M is the best possible character to replace with this question mark? Because if we replace with M, we will get maximum of 2. And if we replace with some other character, and since other characters are greater than 1, that means it is minimum 2 times. That means If I replace other characters instead of this question mark, then we will get at least 3. That means we can easily find by which character we have to replace this question mark. That is that character that has appeared minimum times before. Now let's suppose we replace this question mark with some value, some character m. So in overall frequency, overall count, we will increment the now m count will turn out to be 2 since we have chosen m instead of this question mark. Now for the next question mark, again we will see since all the characters are appearing sometime, so we will again see which character is appearing minimum time. So we can replace that with this question mark. So basically what we have to do, given a string, we first have to find out how many times question mark is appearing, how many times question mark appearing, and we will, instead of keeping at the end, we will not shuffle the string because we have to replace the question mark with that character only. At that position only, we can't push all the question mark at the end and return the answer. We can't do that. But for that intuition, because the position is not impacting the overall cost, because of that, we have decided to keep the question mark at that. Now, suppose if this question mark, if 3 question mark is giving us, so by calculating the frequency, we decided that these 3 question marks will be m. Now the frequency of, after adding this m, the frequency of m gets increased. Now the best possible was a. Now the next is b. Now we know that there is 3 new characters which needs to be replaced by this question mark. That is m, a, and b. Now since, now let's suppose there are the remaining characters are like this. Some now, and we have m, a, b. Since in the question, if you see, they have mentioned if there are multiple string resulting in the minimum value, we have to return the lexicographically smallest one. That means, now since we have these characters, that means, and we already seen that even if I put a first or m first or b first, it will not impact the overall cost. So if I say there are all a's and if I write a and b, it will not impact. If I write BAM, it will not impact the overall cost. That means cost will be same. But since we need lexicographically smaller string, we will replace the first question mark with the smallest character, that is A. Second question mark with the character which is B, second smallest. Third question mark with the third smallest, that is M. So in the overall string, when we will return the answer, suppose in the original string, the position of question mark was like this. Some characters here, some characters here. This is the position of the original string. Now we can easily replace the first question mark with the smallest character, which is A. Second question mark with the second smallest character, that is B. And third question mark with the third smallest character, that is M. So we can see we will get the lexicographically the smallest string after replacing the question mark. So basically, to conclude, I want to say if we are given a string, there will be some question marks. Let's suppose there are Q question marks. Okay. So what we will do first, we will calculate the frequency of all the characters like A, how many times it is appearing, B, how many times it is appearing, C, how many times it is appearing. Now, once we have done this, for every question mark, for the first question mark, let's suppose this is the first question mark. For this, with what we can replace at this moment. Now, suppose there are 3 question marks. For this question mark, at this moment, how we can decide what with what character we have to replace? We will see which character have the minimum frequency, right? We will iterate one by one every character and see which character have the minimum frequency. We will replace with that. Now, suppose Z is not happy at any time. That means we can easily replace with Z. So let's suppose we have decided to replace it with Z. Now, since we have added Z, so we'll increase the frequency of Z one time. Now for the next question mark, again we will see, after updating this frequency table, we will see which character has been appeared very less time. Now let's suppose now we found that M is that character has appeared very less time. So we can easily replace with M. And now after replacing, we will update the count of this also with the new value, or the new count we can say. For the now for the third question mark, again we will see with which character. Now let's suppose it is A this time. Now we know that with these three characters, we have to replace this question mark. Now in which order we have to replace that we don't. So what we will do, once we are finalized with the characters we want to replace, we will sort these characters. Now in the sorted order, it will be like EMZ. Now what we will do, in the original string, we will begin iterating the string. Once we find a question mark, that means we have to replace with some of the characters, which by any one of the character. With which character we will replace? We will replace with the smallest character, that is A. Once we have replaced, we will remove this. Now again we will find a question mark. With which character we have to replace? Next smallest, that is M. So we will replace with M. Again we will iterate. Now we will find a question mark. With which character we have to replace? The next smallest, that is Z. So in this way, we can easily find the lexicographically smallest string where the cost is minimum. Cost is minimum. If we look at the code, so what I have done, we have taken a frequency vector to calculate the frequency. In this, I will be pushing the characters by which we have to replace. That means once we are finalized with the character that we have to replace any of the question mark with this character, I will push in the miss vector. Now this is Q, which will count how many times question mark is appearing. So I will iterate and updated the frequency table, as well as I have counted how many times question mark has appeared. For each question mark, I will find out which character has appeared minimum time. And once I got that character, I will update the frequency table and will push in the miss vector. That means this is the one character which I have to replace with any one of the question mark. Now what I will do, I will sort this miss table, miss vector, so that at the beginning I get the smallest character. Now I will again iterate the string and see if the character is question mark. That means I have to replace with some of any of the characters. So which characters? So K will indicate the current smallest character. Current smallest characters. So I will replace the question mark with this character and increment the counter. So at last we can replace this, return this string. So I hope the problem statement and the solution is clear, and I hope you have find the intuition behind it. So if we see the time complexity of this solution, so for one time we are iterating this string to calculate the frequency as well as the number of times question mark is appearing, that is big O of n time. In the second time, how many times question mark is appearing? For each question mark, we are running a loop of 26 to find out the minimum, find out the character that has appeared minimum times. That means, let's suppose in the worst case, the length of the string is 10 to the 5 and all the characters are question mark. In that case, we will run 10 to the 5 into 26 times. Again, it is kind of a big O of 26n, big O of n, we can say. So it is overall big O of n. Now, for the third time, we are replacing the question mark with the characters. Again, we are iterating it one time. That is big O of n. So 3 times big O of n. That means overall, the time complexity will be big O of n. If we talk about space complexity, there is a frequency table that is 26 into some integer value. For every character, we are calculating the count. That means big O of 26. and other we have taken a constant, we have taken an integer variable to count. And for here I have missed one part, that we have sorting also, that is b, n log n. So instead of sorting, if you see, I am doing the sorting, that means it is taking n log n time. So instead of sorting, you can do one more thing. Like we know that A is the smallest character and Z is the smaller, biggest character, largest character. So instead of sorting also, what we could have done, that again we would have taken a vector of 26. Now once we have decided that we have to replace any of the question mark with A, then we have easily go and increment the counter of A. That means if the counter of A is 5 at the end, that means there are 5 question marks that has to be replaced by 5 A's. So we can easily we have iterated this and this miss vector one by one from the character A to Z and would have replaced. So in the constant, in the contest, I've just used this sort function. So you could have used this vector also. So in that case, it would have taken 26 into n. While replacing it, it would have taken 26 into n. That is again a constant. So overall, it would have taken big O of n. But in my case, since I have used the sort function, it is taking big O of log n time. And space is constant. So in my case, since I am pushing every character in the vector, so it is taking for every character. That means if the in worst case there are 10 to the 5 question marks, then that means it is taking 10 to the 5 space. So in my case, since I have used the sort function as well as I am for every character I am pushing in the miss vector, it is taking big O of n space also. But you can easily reduce this to big O of 26 and time complexity to big O of n. I hope the problem statement and solution is clear. See you in the next video. Thank you.